Hi, it's James from Enso. Today I'm looking at day 7 of Advent of Code. As before, I've already loaded in the example, a link to my own real dataset, and the text of the problem. What we need to do in this one is work out how a set of beams pass through a grid of splitters. We'll start by parsing the data into something I can work with. So let's use a parse the table function. I'm going to pass a regular expression that will extract the actual text of the bit I'm interested in. And the regular expression I'm going to use in this case, I'm going to create a column called value, and I'm going to look for anything that isn't a new line and just put that into a set of columns, into a set of rows. So that gives me the table as lines. Then I'm going to add a row number, as this is going to be useful for later. And then I'm going to split this into rows, splitting the value, splitting on every character in it into a new row. And then now I'm going to add another row number of the column. So this will give me the input passed into a row-based table containing all the values that are in the grid. We also need to make this column number reset at the beginning of every row. At the moment it's just increasing, and we can do that by grouping by row. Now I've got a correct row and column number and the value at it. Let's now work out, we want to look at the row below, and I'm going to do that by drawing the table back to itself, but looking at one row below it. I'll do that by creating a new value of row plus 1, and we'll call that next row index, and drawing the table back to itself. We're going to do a left outer join because I want to keep the input table complete. And I'm going to join on column, next row ID, joined to row. And I'm going to name this next, just to make it a bit cleaner. Let's have a look at what we've got. So in the first row, the next value is dot always, which is right. But then if we look on the one below, we've got a caret appearing, which indicates a splitter. Let's just tidy up and remove the columns I don't need. So I can remove columns. I don't need the row index, the next row, or the next column. We're now at stage, I think we're ready to try and work out what happens when the beam passes downwards. So what I'm going to do here is I'm going to produce something that we can iterate over the whole table and go one step at a time. So I'm going to first get a constant that is the row count and create a range by using the up to function to create a range. So what I want to do is on a row, I want to process it one row at a time and decide what happens on the row below. So what I will do is let's build up an example of this. So let's assume we're starting on row 0 because that's the first data set. I want to filter the table to get the values on that row. So I'm going to filter row equal to that one. And if we now look at this, I want to look and see what the next value is, and depending on the next value, I'm going to update the state of the current value. So I'm going to build a small lookup table to help me with this. So let's use the table.input function. And let's build up what that lookup for table should look like. So I'm going to have the next value being the value I'm joining on, if it's a dot or if it's a caret. And I'm going to need a couple of values for that. So we're going to affect 3 columns on that one. And if it is, I'm going to do column shift, so we'll call that shift. So if there's a dot, I'm going to pass straight downwards. So then I'm going to say that the new value for that is just pipe. Otherwise, and that's fine. So, and then on the one on the caret, what I'm going to do is I'm going to change 3 values around it. So the ones that it goes to the left and the right, where the beam's been split, I'm going to make those have a bar, same as if it went straight through. But for the caret itself, I want to replace that with a star, so that I know that that one's being used, which is one of the things we need to look at. I only need to process the cases where there's something in there. So I'm going to filter where the value is in. So we're looking for either the initial value, which is S, or the separator, or the pass-through symbol, which is bar. And now I can join this together and see what we get. So I'm going to join this. Join it to the lookup table. I'm going to do an inner join, and we're now going to change the join condition to be next value is equal to next value. So we have a look at this. In this first case, we're moving straight down, so we add just a simple bar. If we had a caret, let's go and put one in and see what check that will work. So if we had a caret here, put it in the right place, then we should get it splitting and doing that. So that's looking good. So let's put that back to having the previous value and check. Right. So now what I need to do is combine column and shift to map between the columns we're now working on, and also combine with row to the next row. So we can do that using a set, looking at an expression, column plus shift, and call that column. Here we're going to call row plus 1 and call that row. We're now saying we're adjusting row 1 and column 1, and then we're going to put the next value in. So now let's just select the columns I'm interested in. We're going to select row, column, and next value. Serve the order. And now I'm going to rename next value. And we're just going to call that value. And now I'm going to group by row and column, taking the first value of value. I'll tag that as value again. And that should give us a table we can then apply back to the original table to account for the move of one row. So if I take the original table, I'm going to merge this, this produced changes. I'm going to merge it on row and column. I'm not going to let it add new rows because that would indicate there was a problem, add new columns. But that should have now, if we have a look at row 1, updated row 1 to have its new value. Why did that not work? Let's just check. That's got a value of dot. Why has that got a value of dot? Ah, I didn't want next. I wanted new value, not next value. So let's correct that. So we want new value, and we want to rename new value to value. And let's check again. Check row 1. That looks good. Perfect. So now what I want to do is I'm going to take all of this component and make it into a reusable function. So I'll click this button here to create a function, and we'll call this perform step. We'll do a refresh to get it to initialize the new function. we'll detach the input and put the integer in as an input, and then I will copy and paste it. We'll check one more step to make sure everything looks like it's working correctly. Let's have a look at row 2. And indeed, having been through the split, hit the splitter, we've created 2 beams and marked that we hit the splitter. That looks perfect. We now want to repeat this over every row in the table. So I will fold over the set of rows, passing in the initial table. So move this out of the way so we don't get crossing lines too much. And I need to pass in the function, which is perform step. Pass that in as the function and let it run all the way down. Let's have a look at the last row. Oops, it's got the wrong window. And we've got a load of dashes, and just above it, a load of stars, and one indicating that we missed it. So for part 1, we need to count how many times we hit a splitter. So I can do that using a filter where the value is equal to star. Let me get through 1. Last part, switch over to the real data source, and let's see what happens. 1,640, and that's my answer for part 1. I'll pause the video and load up part 2, and let's see how we do that. Okay, I've loaded in part 2, and let's switch back to the example for a second. So in this case, we need to count the number of different paths to get through everything. This isn't a huge adjustment on what we had before, so let's see what we need to do. I'm going to start by adding a new column, and I'm going to do a new expression. And I'm going to say in this case that if the value is equal to s, then we put 1, else we put 0. Now this is the path to get here. So I'm just going to count every time we go down, split, but we keep the part count going. And if we combine, then we need to add the 2 routes together to get the total number of paths. So let's start by putting that in and feeding that into our perform step function. So if I now go into this function, but most things are exactly the same, except for what we now need to do is we also need to now aggregate the number of paths. And I can do that using a simple sum. And I'm going to sum. Has it not come through? Where did I drop it? I need to keep the paths in the select columns as well. And we then need to sum paths, and we'll call that one paths. There's one correction that I also need to make, that if I am on a star now, the paths should be 0. So I'll do that as a small correction afterwards. Function. So here we want to do an expression and say if value is equal to star, then 0, else paths. And we're going to update the paths for that. And then we'll plug that into the lookup table. And let's go back and have a quick look at what goes on with the data. So we're getting an error on the fold because I haven't changed the input connection to include a pass column. So let's just switch that over. And let's just do a sanity check and make sure everything looks good. So we get down to here and let's check what's going on row 2. So at row 2, we've got 1 path to get there each time. Looks promising. Let's have a look and see what happens. Oh, that's not the one I meant to see. Let's have a look at the output of the fold. And let's see what was happening on row 3. So that carries on passing down. On row 4, when we now hit, and that's looking good, except for the fact we've still got 1s on these stars. That looks like we've got a problem because we want those to be 0. So let's go back into the performed step and just check the logic I put in there. Oh, the expression must not have saved, so let's correct that. If the value is equal to star, then we want 0, otherwise we want that in, let it recalculate, jump back out. Let's have another look at what's going on. So on our first split, we've got 101, that looks good. And then when we have two splitters, we get 121. So that's looking promising. So last thing we need to do is on the lot, we now need to look at the last row. So we'll do a filter. Where the row is equal to the row count, except we need the row count minus 1 because the count rows are indexed from 0. And then we want to do the aggregate of a sum of the number of paths. And hopefully for the example data set, we're hoping that comes out as 14. So let's have a look. It's good. Let's plug in the real data set. Let it scan by. And then hopefully we will get a large number. Is the number for my input data set. And that completes part 2.